So the topic for this one is a topic that I really quite enjoy myself. It's something that I came across many years ago, and it really spoke to me. So it's something that I always sort of train my colleagues on, and junior people when they join, because I feel like it's really quite an important distinction to make. So, and, you know, this concept of iterative or incremental development. So I'm going to try and explain what I mean by this, what some other people mean by this, and see where we get. All right. So, and just a free shameless plug. I'm starting out to trying to make like a YouTube channel called the Agile Broadcast, and I'm trying to make videos online where I explain concepts and things like that. And I've sort of already explained that concept in one video, which is Agile Incremental or Iterative. I'm basically going to cover the same things. So you could just leave this meetup and watch the video, but that's no fun. So please don't. Stay here. We're going to talk about it live, basically. But it's a good video. I would say that, wouldn't I? But it's a good video to talk about the topic too. So if you're interested, have a look. All right, enough of that. Right. So I'm just gonna. I mean, we all probably know what this diagram is, right? The Scrum process, which is fairly standard. Everybody knows this. And the reason I bring this up here is because, well, when you say the word increment, people tend to think about this, right? The little thing you produce at the end of a sprint, right? The product increment, as it's called on the Scrum guide, right? And the iteration would be the actual sprint, right? The length of time that you've taken to produce that increment, right? And that's kind of how most people have found see those two words, right? That's all it means, and nothing else. But what I'd like to propose here is that there is a deeper meaning to those two words, and it might be a bit of a semantic game, but I think there is something quite interesting there if we go quite deep on this. So, which is what I'm going to try to do here. So, for this, I'm going to need the help of this guy, Jeff Patton, which, if you don't know him, is the author of the story mapping book. It's called User Story Mapping. So story mapping is a technique that he kind of came up with, and he wrote this book on that. So I can't cover story mapping in this. It would take too long. It would be an entire session on its own. But if you don't know the technique, I really recommend you have a look at this. It's really quite a powerful technique that I use pretty much all the time in pretty much all the projects I worked on. Really quite useful. And in this book, he started to actually describe the difference of what he thinks about iterative and incremental. And for this, excuse me, he uses the analogy with the Mona Lisa as a painting. So if you were to paint the Mona Lisa in an iterative way, that's kind of how he was visualizing it, where incremental would look like that. And just visually there, it's quite a powerful metaphor here to understand what he means. But before we go deeper into this, and I'm going to go deeper into this, I just would like to go back to basics a bit, because I think it's important to be a bit explicit about this. So apologize for the experts out there. It's perhaps a bit basic, but I think it's important to go through that. So if you were to plot, let's say, your features on the x-axis, and on the y-axis your architecture level. So most software product will end up something like this, right? Or something similar to that, with different layers, right? Different technological layers. So you might have a database layer at the bottom, right? And all the way at the top, you have the graphical user interface, and all the various layers you might have in between, right? Whether it's a logical layer with a model, or whatever layer you may have, right? And all of your features probably have a bit of a user interface and a bit of a database, and everything in between. Yeah. So every single feature, we go through all the architecture layers, and a lot of teams tend to lots of teams who haven't done really much agile work will tend to organize themselves across those layers. So you'll have the database team, and then the graphical guys, the UI experts, in perhaps even in another room, or even if it's in a team, you might have individuals specializing in those things, and then the database people will work on the whole database, and then the user interface people will work on the whole interface, and then they try to make it work eventually, right? Hoping that it all fits and it all works. Of course, another way to slice things, so this would be horizontal slicing, right? But another way to do this is vertical slicing, where you look at each features as an entity on its own, right? So each feature would be those vertical slice where they have all a bit of UI and a bit of a model and a bit of a database, and that would be vertical slicing. And vertical slicing is a thing that you can see in Agile textbooks. People talk about this a lot. It makes a lot more sense when you're sprinting. You can decide, on a few vertical slices for your sprints, and at the end of that, you have a fully functional feature, right? As opposed to a bit of database that's not connected to anything, or bits of UI that doesn't have any database to back it up, etc. Right? So this is kind of the basics, right? So horizontal versus vertical slicing. And the reason I'm talking about this is because it's going to link quite nicely with the whole Mona Lisa analogy, right? So incrementing, right, which is what Jeff Patton means by incrementing here, which is basically building bits of stuff at a time, right? So if you look at the first picture, you have just the top of the Mona Lisa, right? The top of the head. It's not even the complete head, it's just a bit of it, right? And then second step, you have a bit more, and then third step, you have a bit more, and then eventually on the fifth step, you have the whole thing, right? Now, of course, no painter will paint any painting like this, right? This is just not how artists would work, as you can imagine, right? But this is what building something bit at a time would look like, right? And in fact, this is how I see most software being built, right? Where we take a feature and then we build it fully, and then you move on incrementally, bit by bit, right? But the problem with this is that on step one, right, you have to already know what step 5 is going to look like, right? You've got to have a pretty good idea of what the final product is going to be at a lot of detail, right? Like if you look at the use your pen here. If you look at this part here, right, on the head, you have lots of details already decided. Everything has been decided. The tone of the background, the size of the head, the color of the hair. A lot of details have been already decided upfront on step 1. It's going to make it very hard to change your mind, right? And if you got that little bit, those decisions wrong, right? It's going to be very hard down the line to change your mind, right? So if your proportions were wrong, you might have run out of space, right? You couldn't draw the hands properly or something. But I hope you get my drift there, right? And basically, because you have to have this idea there, fully formed idea already, it's actually not that different from waterfall, really, because you have to have made a lot of decisions up front, right? And to be on time, you've got to have pretty good estimates, right? You have to know what you're doing. It's almost like you need to know, you need to have built this thing already before you even start, right? Now, iterating, and again, in using Jeff Patton's terminology here, would mean this instead, right? Where you build a rough sketch first, right, on step 1. And as you go along, you sort of validate it, you slowly build up the quality, let's say, of the system, right? And eventually you get to step 5, where you have something that looks like the Mona Lisa as we know it, right? And you can imagine that this is how an artist would actually work on such a painting at first, right? Because they don't necessarily know exactly where they're going to end up with when they start. They're going to have a rough idea, right? And as you can see here, we had the hand here that was at the top, and you could change your mind and say, actually, I don't like this. I'm going to put it back down here, right? But because it's just a sketch, it's cheap, right? To change your mind, it's easy to do that, right? On the previous point here, if you want to change the position of the hand, well, this is quite tough, right? Because there's so much detail already made. It's going to be really expensive, take a lot of effort to modify that, right? Where here, it's much easier to do that. Does that make sense? Yeah. So again, here at the beginning, right, you don't really need a fully formed idea of what the end product is going to be. You just need a sort of a vague vision. You need some kind of woman in some setting. And that's all you really need to get going, right? So in my head, being iterative or doing this kind of makes more sense in a world of Agile, where you just have a vision, you don't know the details, you don't want to work out all the details anyway, and then you're slowly evolving your system over time. Yeah. I don't know if David is here. He said he might be able to turn up. But so David Love, he's actually based in Wallingford, so not so far from you, Kirsty.
Well, I live in Oxford, but yes, I just work there.
Okay, sorry. Yeah. So he lives in Wallingford, and he's
David actually. Just a correction, David lives in Bainson, which is a little village near Wallingford, where I live, where I happen to live as well. It's such a weird coincidence.
Oh dear, small world, small world.
Yeah, but Wallingford is like the postal town.
I see, because it says Wallingford. I just assumed wrongly, you see.
No, it's...
What did they say about the word assume? So he wrote, and then just for the little advert for him, he wrote these 2 books, which are pretty good. So he's quite a well-known guy. He's a trainer. He does a sort of agile coaching and business coaching as well. He's a really good trainer. And the reason I mention him is because, well, he's a bit of a neighbor. He's in our local community, but also because he sort of came up with a different sort of visual analogy for this incremental iterative sort of thing. He came up with this kind of drawings, where if you were to build like a town in an iterative way, so you always start with like it's the wild here, right? You've got nothing, and straight away you've got like the rough patches of roads here. Nothing too serious. It's just like a dirt road, and then you have perhaps a better road, and then you increase the quality of the road, let's say, until you have the proper roads like you would expect in a town here. Where incremental would kind of look like this, right? Where you just built a bit of road, but it's a perfect type road, right? It's the kind of road you get at the end here, but you get that right from the start, but you don't have everything, and then you just build your town bit by bit like this, incrementally. Where the Big Bang would look maybe more like this. So it's a sort of different analogy, really different pictorial representation of exactly the same idea. Right? And the reason I bring this up is because he's also made like a game with little cards, which, if you can see on my video, I've got with me here, right? So, and I wanted to do this at the pub, but we can't, right? So, but I would like to somehow try it anyway. We'll see. It's a bit experimental. Obviously, you don't have the set of cards. I do, but
I do too.
Oh, you have it. Excellent. So it's a nice neat little set of cards, and I will try to. So let's go. I will ask you if that's okay to go to this website. So you can go to pointingpoker.com. It's a free tool, and then just join a session with that number, and then we'll be able to do this. It's like a planning poker for people who know that. When you estimate stuff, but I've set it up so that we can do incremental versus iterative versus Big Bang. Right, so I've got the deck in my hand, so I'm just going to pick a card. And so the point of the game is it tells you basically some scenarios, right? Like real life scenarios, nothing to do with work, right? Nothing to do with software project necessarily, just real life scenarios. And the point is to say, okay, would you build this incrementally? Would you build this iteratively? Or would you do like a Big Bang thing? Yeah, does that make sense? So I'm just going to pick a card. There we go. So I'm going to type it there. So learning a new language. So again, right, learning a new language is, would you do this Big Bang? You learn everything in one go. Or you do it bit by bit, or you somehow iterate on it.
No, I'm mixing them up. Yeah.
Hollandesha. One more vote.
I think this has a lot of too many denominators.
Yeah, it's working fine. So show the votes. Boom.
I have been a teacher of English in the Netherlands.
Yeah.
So it very much depends on how you're trying to learn a language. because if you do it in a classroom, there's obviously a plan, a sort of year plan, and you have goals by year. But if you would do it by yourself and you go to one of those newfangled apps on your phone, then it's, you pick it up as you go, basically.
So it's interesting that nobody said Big Bang, right? Which is good. That makes sense, right? If nobody's going to like learn the whole language and never speak it, right? And then suddenly start to speak, right? But there's a kind of even split between iterative and incremental. So, so Kirsty, what did you say? Iterative, yeah, that's what I would do. That's how I learned English when I came here. That's how I learned German.
Yeah, but it's not iterative if you're taught it in school. That's what I'm trying to say. Then it's incremental. So it depends on how you're taught.
So can I ask, you don't think something like Duolingo is incremental?
No.
Why is that? Sorry.
I think you can pick and choose your themes. You can go through it as fast as you can. And at least how I did it, when I tried to pick up some extra Danish, for example, I tried to also watch television with subtitles. So I sort of jumped into the deep end. So it's just much more of, okay, now I'm finding so many words. Let's try and look a couple of things up, go back a couple of lessons, and then sort of going back in loops.
But there's a bit of learning science behind it, isn't there, really?
Yeah.
So you could argue that it is incremental because it is, whilst you have a facility to kind of jump around, it is trying to guide you incrementally to an end goal.
Probably has a bit of both, really.
Yeah.
Yeah, I would say a bit of both, because you start with a small part of the picture. You don't perfect that, but you move on to the rest of it. You don't have a picture of the whole language kind of before you start. You don't learn the whole language in a rough way before you start.
I'd say it as well, because you don't really do grammar when you go and Duolingo. You just learn separate words with no sense of why you're doing it.
Which is how kids would learn languages, right? It's not like you teach them; they just pick it up, right? They just say badly. They say badly for many years, and then they just sort of increase their, how would you say?
So you don't start with an architecture. You just start here. You've got a couple of words. Good luck with it.
And that's the incremental bit where they learn new words every now and then, but there's an iterative aspect where it's quite rough. They make mistakes, but it's okay, and then it evolves that way, right? Cool. All right, next card.
It's interesting that I feel that I learn iteratively, and yet if I was teaching it, I'd teach it incrementally, because I'd go, come on, let's talk about what we're going to learn at the grocery store and then how to get to a train station. I'd expect to iterate over that in order to actually get good at it.
It's interesting you use the word teach. I think teach is the crucial word there, because that's the kind of the educational format that we've always kind of transitioned into the workplace, and we all know the workplace has changed in terms of how learning is carried out now, or it should be anyway. Anyway, so I think we're probably holding you up, aren't we?
That's fine. Yeah, it's a good discussion. As opposed to when you learn on your own iteratively, perhaps more naturally. Something like as complex as this, right? But anyway, next card, right? Because there's a few, but we can't do them all, obviously. But all right, what do I've got? I've got, as you can see, putting a man on the moon. I'll type it. So clear votes. Boom. And I can't type. All right. Putting a man on the moon. How would you do that? There's actually some interesting talks about this on YouTube. A few agile people who use that as an analogy. Couple more. Any idea? No, Wilson, that's it. Decision made. Gusia, you're the only one left. No pressure.
Am I? I think I'll be the only person not voting in this to leave.
That's fine. Let's just show the votes. Cool. That's a nice big sample. Cool. Arabella, can I ask you, Big Bang, how did you come up with that? What made you think it's Big Bang?
Well, if the objective is to put him on the moon, you can't kind of navigate there in stages. You can build everything in stages, but then the physical point of the man being on the moon, it just happens all at once.
Well, the objective is binary, right? For sure. Like you get there when you get there. You can't just get there a bit, right?
Yeah.
Yeah. But I guess how would you get there bit by bit, right? As a project? So someone who went with Incremental, would you like to expand on that?
Yeah. So, I mean, the objective is to get the man on the moon, but actually when you started that, you had no idea how to do it. So so the first time you launch a rocket is to take you, say, out of the atmosphere. That would be the first step incrementally, and you'd see how that works, learn from that, and then take the next step. So although the objective is get to the moon, you would still have to learn how to do it as you go.
Yeah. Yeah.
So it's a bit like any science, really.
And then what about iterative? Someone said iterative.
Yeah, I'll make a case for that. So iterative, because you don't know everything, so you kind of know roughly you need to build a rocket to send it off towards the moon, but you need to be able to test it along the way. You need to be able to adapt and be able to pivot when you haven't got the right answers and all of those good things. So I think you build it up iteratively to build those slices, because you're building on building the rocket, you're building on building how do you actually land on the moon, life support systems, all of those things you're sort of doing at the same time, and you have to just keep working the problem, keep testing along the way.
I guess if you look back in history, they probably had lots of missions where they would just put something in orbit, and then they would have someone in this, like a human being. First, maybe it was a monkey or something, or a dog or whatever, and then first they would go to the moon, but not land, right, and come back, and then they would go and land. And that feels iterative to me, right? But there's certainly aspects of incremental in there for sure.
If you look on YouTube, there are some great compilations of all of the rockets that have blown up by SpaceX on their way to getting cool stuff to happen. So they've definitely learnt through failure along the way.
Yeah, very cool. All right. I had maybe another one, and then we can move on. Just looking at the time. Oh, that's interesting. All right. Let me clear this up. Clear votes. Okay. So learning to play the guitar. I see you've got guitars behind you, James.
I'm very interested for people to explain to me how I should learn that.
That's an interesting one.
All right, boom, show the votes. All right, no Big Bang there, no surprise there, I guess. A lot of iterative. So someone would like to explain why they chose iterative.
Yeah, I'll go because I'm a drummer.
Have a go, Nick. Yeah.
So I'm self-taught. I had a few lessons for a little bit, but then I'm just predominantly self-taught, and so I think iterative is really, for me, is about, I don't think I ever kind of grew up thinking, well, I did actually, thinking, all right, I'm going to be such and such drummer. I just think over time I've just developed my own style, so that's why I've kind of gone for iterative, really.
Yeah, makes sense.
I found it hard to choose because how is this different from learning a language?
Yeah, I agree. It's probably a bit of both elements in there, right? So what about someone who picked incremental as the main thing. Wilson, what do you think? Where's Wilson?
Yes, it's I'm here. Well, to be honest, I have bought a guitar more than a year ago. I've been trying to do something, but I think I'm just lazy. So I said incremental. I said incremental because I've tried to learn some chords, but then I feel that it doesn't work as well, to be honest, because you can't do much with just a chord or two, although I've tried. So yeah, well, I think it's a mix of incremental and iterative, to be honest.
Yeah, I think I agree with that. So when I learned many years ago, it was there's certainly bits of it were incremental, right? Because I couldn't do the bar at first, right? So I had to pick the songs that I would make that didn't have a bar, so I could just play them, right? So there was an incremental aspect there, right? But then it was definitely iterative, where I would just take the main chords of a song and just do those, right, and not all the details, and then over time try to add more detail and more refinement on the song. So that was definitely iterative, right? So there's again a bit of a mixture, right?
I'd change my answer actually. I'd say it's probably more incremental than it is iterative, in the sense that I don't know anybody who's tried to learn guitar and from day one gone, you know what, I'm going to pick up some chords, I'm going to learn to read a tab, I'm going to do some scales on this thing, I'm going to do some plucking, and let's slide a capo on and do some bluegrass. It doesn't really work like that. You normally start in a relatively fixed domain and you do iterate a bit until you've kind of grown there. But you are again taking, you know, a big picture and very definitely slicing it into a chunk and going, here's the chunk that you should kind of get some level of competence on before you kind of grow out.
Yeah, so that's interesting, because what that makes me think of is the whole sprint zero thing that people talk about in teams, right? Because often, as an agile coach or a scrum master, you say, okay, let's build something of value right now for the first sprint. But then the development team goes, well, we can't. We need to install a database. We need to install a continuous integration thing. We need to install this and this and that and all that plumbing. And that's just incremental. And before you can build anything that looks like anything serious, you have all these things to put in place, all that plumbing to do, and there's just no other way. So this feels very much incremental, and once you have that, right, then you can sort of iterate and improve on things. So
can I just add the other? It's made me think a lot. The other analogy for me from a drumming angle is no one really cares how you hold your sticks, as long as you can just have got good time and you can knock a beat out at the end of the day. They're not looking at your technique. The only people who are watching you are the drummers in the audience. Well, it's true, but I think it was just going back to what Kirsty was saying about different from learning a language. And I think, well, I'm not sure, because I don't know if people are kind of going, oh, right, is that guy holding those sticks correctly versus, oh, did somebody just, mispronounce a word or something? Or,
you have no idea.
How much flexibility do you have people going, oh, right, okay, actually, I in the context of what you were saying, I understood you to say this and you came out that way, but I'll forgive you.
Yes, unless I still pronounce stuff wrong occasionally. One of the funniest ones is it's a very bright pink color, which in English they would say fuchsia. In Dutch, I would say fuchsia. And then you get completely different annotations.
Yeah.
So there's still those things where you can still be misunderstood and can still learn.
Sounds good. Cool. Thank you. I think just looking at the time, I think I'd like to move on. But if you're interested in that game, have a look online. So if you go back to the screen sharing, and I'll move on from this thing up. Right. So if you're interested, there's a link here. If you're interested in that game, it's quite a cool little tool for your teams. Right? If you're trying to introduce these topics to your teams and get them to think about the difference, like we've just done. Right. It's really quite a nice little thing. So have a look. There's a link there, just there below. All right. Now, so I'd like to go even deeper in that topic now, because I'll steal some stuff from Carl Scotland here. I don't know if you know him, but he's a kind of big name in the Kanban sort of world and Lean as well. And he's got some kind of nifty stuff about this. So he's introduced many years ago now this idea of fidelity. I don't know if you're all familiar with that concept. Maybe kind of quick wave if you know about fidelity. Yeah, couple. So the idea there is, so if you're building a road, and that builds up nicely from David's little analogy earlier, that so you're building a road, you have to go from A to B, right? Maybe you don't want to go to this solution straight away, right? Because it's expensive to build, it'll take a lot of time, and if you get it wrong, then you know it's going to be quite expensive to fix. So maybe the first thing you want to do is build this kind of road, right? Like a dirt road. It's cheap to build, it's much faster, right? And you can validate the fact that you actually need a road, and the fact that you're going to the right place, right? From A to B. Is B the actual location you want to go to, or was there another location that was better, for example? Is this the right path? Was there a quicker path, a better path to get to B, etc.? So if you want to validate those questions, doing this first makes a lot more sense, right? And as let's say your confidence level on what you're building being the right thing to build increases, you can sort of move from there to there, and then from there to there, right? Where you increase what he calls the fidelity of the solution. So here it would be like a low fidelity solution, right, for your problem, and on the other side it would be a high fidelity solution, right, and everything in between. Yeah. Now, a lot of people confuse the term fidelity with quality, right? You could easily, in the everyday language, say, oh, well, the quality of the road has increased here, right? But there would be a distinction here, right? That it could be, this dirt road here could be a really good dirt road, right? That you don't get any, there's no nails in there to go in your tires, or right, or it gets to be in a rather efficient way, right? Etc. And same for that stone pebble road here, right? It could be a good quality one. So if you make an analogy with software, let's say a low fidelity solution could be a command line tool, right? There's no graphical user interface, let's say, right? So it's rather rough, right? As a solution, people might expect more, right? But as a solution, it might still work. It might be complete. You might do everything that needs to be done, but it's just you know, a bit rough, like that dirt road. But the quality can be high, right? There's no bugs. It doesn't crash. It's fast enough. It's performant. It's robust. It scales, that kind of thing. Right? So not the same as quality, really. Yeah. So now, does that make sense before I move on, actually, on this fidelity concept? Yeah.
Yeah.
So with this in mind, we can add this to the feature architecture graphs I had earlier. Yeah. So if you look at this horizontal slicing graph that we had earlier, which is basically the same as a Big Bang delivery, right? Because you need to build everything, and then once you have everything integrates, and then you have something, right? So it's kind of Big Bang here, Big Bang delivery, Big Bang theory, Big Bang delivery. So here's the same graph, right? But now it's 3D, right? So you have the features or the scope, same, and then the architecture, so same graph, but we added fidelity here as a z-axis going up. Yeah. So if you think about it, that Big Bang way of building things would be that you build layer by layer, right? And I mean architectural layers for the whole scope. So like the whole database, the whole model, the whole UI, and you do everything at full, fidelity, like high resolution fidelity solution for everything. Yeah. And then the problem, of course, with this, it's not incremental, it's not iterative, really. You're just building stuff, but you only have something working at the very end, right, where everything integrates together. If you're doing things incrementally, so remember the Mona Lisa, right, bit by bit. So here you're still at high fidelity levels for everything you do, right? You just build it the other way around, right? For each, so you do vertical slicing, yes, because you're building your scope bit by bit, but each feature has the full architecture layer. So for every feature, you have the UI, the model, and the database, let's say, right? but everything is at high fidelity, like for the Mona Lisa with the head and the background, full details. And you build stuff one by one, right? That would be incremental. Now, iterative would look like this, right? You're literally building up the fidelity, right, of everything. So you first you build everything, the whole scope and the whole architecture, right, but at a very low fidelity, and then you increase the fidelity as you go. That would be the a pure iterative approach, right? Now, and I would argue, and I think that's what we saw with the card game earlier, that really, most of the time you have a mix of both, right? You have a mix of incremental and iterative, which I would argue is what an agile delivery is like most of the time, right? Where you have a bit of a mix of everything. Does that make sense? Now, I think what's interesting on that little animation, and that goes back to James, your point earlier, right? The first bit there is incremental, and then you build iteratively, right? Because there's no other way, really. You have to build your thing incrementally first. So if the first layer is like your MVP, let's say, right? You have to build that incrementally. I mean, it has to be bit by bit until you have something of minimal value, and then you iterate to make it better, etc. Does that make sense? Yeah, looking for a nod. Yep. Cool. So the interesting thing here too is that if you look at the final picture, and can I stop the animation? I'm not sure. If you have a picture of the final bit, right, you're going to have a landscape of fidelities, right? Well, that's quite interesting to me, because what that means is, as I'm trying to do with my clients a lot, is say, okay, do you really need full fidelity in everything, or do you end up with you know, a bit of a profile, a fidelity profile, let's say, where some features are maybe the most important things you're building, right? They're the key features, the key differentiators for your project, right? The thing that makes you different from, let's say, competitors you may have, right? Or competing products. So you really want that fidelity to be really high for this. But the rest maybe just needs to be lower, right? Or even very, very low, right? So if you're building a car, let's say, I always bring that example. If you're building a car, and your thing as a company, right, is to have a really good braking system. Like, let's say you've invented the new ABS, yeah, for your braking system. I mean, obviously that ABS system needs to be at high fidelity, right? It needs to be really neat, because that's what people are going to look at. That's what they're going to judge your results on. But the rest of the car can probably be at a relatively low fidelity. I mean, you don't want it to be really low fidelity, because people get disappointed, right? But you don't need a super engine. You don't need a race car necessarily. You don't need a Ferrari for this, right? If you're trying to sell your ABS system. Does that make sense?
Can I ask you something?
Yes.
We're mostly working with a must, would, could, and should idea. Is that the same?
Is that the same?
Because basically what we're saying is we have all these features, and some of them we really want in it, and they need to have this, how do you say that? They need to work in the right way. The woods is basically this, yeah, it's really nice to have that. And the should is, yeah, well, if we have time left, we might, kind of thing.
Is it the same? So I'm just thinking, is it the same? In my head, it's I would use the Moscow things as well a lot for prioritizing, of course, like most people do, right? But is it the same?
I'd argue, David,
not in my head.
I'd argue that it's not the same, because even if you've got something that's a could, you're unlikely to get to it in any shape or form. Whereas with fidelity, you're saying, well, you may need a lo-fi version of that. So in my mind, it's not quite the same.
And in fact, I have examples where it's totally opposite. So, I give you a good example for that. So reporting, right? So a lot of systems, you need some kind of reporting system. Like, you know, the people want some kind of PDF report or something to be able to send to their managers or whatever, right? Now, does it need to be an automatic PDF, all singing and dancing that looks really nice, or people just want to send the data by email or something. So maybe it's just a screenshot, right? And then you copy paste on an email, and that's it. That's your report. Maybe. I mean, maybe not, right? But it could be that really you focus on the actual product. Maybe, let's say it's a calculation engine, let's say. So really that needs to be quite high fidelity, the calculation. But the reporting could be very low fidelity, but it must be there, right? Because if it's not there, they can't report to their managers what they've been doing. So from a business point of view, it's a must, right? They must have a way to report back up the management chain, let's say. But they don't kind of care how neat the feature is. It just needs to be there, right? Does that make sense? So like if you're building a car, right, you do need wheels and chassis and the gearbox and the engine and all of that. Otherwise, you don't have a car, right? You need all these elements in there. So that's the incremental part, I guess, of what I'm saying. But you know, again, you just need wheels, right? If your thing is the engine, you just need wheels, right? They don't need to be super wheels. Does that make sense?
You see, it's interesting because the bit that bothers me about this animation is that it goes across doing everything at low fidelity before something starts going up. Yeah. And actually, I can kind of see that if you take the leftmost one as being your must scope, and then your should, and then the final two blocks are your coulds. There's, you know, typically your backlog's kind of divided that way. So what we're doing our musts, then we're moving on to doing our shoulds, then we're doing our coulds afterwards. So our scope is kind of broadening that way. But it should be that once we've released our musts to the market, right, that we start learning something and that the fidelity of those starts improving. So I kind of expect for the leftmost ones to start going up before we've got all the way through the scope.
Oh, I see. Yeah.
I also think that must, should, and could are useful for determining scope, and this animation that we're looking at now might be how we approach our must-do features for the scope, and then, as you said, then the next lot might be our shoulds, and then if we've still got budget left because we've done brilliantly, then we tackle the could. So yeah, what James is saying, but yeah, must, should, could for me is about having conversations with the business about scope and trying to get them to understand that if every single thing is a must, you're going to run out of budget before you've got something useful.
David, I've asked you something privately in the chat, but I'm
I saw that now
because I didn't want to look like an idiot in front of everyone, but I've done that earlier. I've just remembered. So my question was,
go for it.
My question is, if there's iterative, I'm trying to make sense of what I've asked here. If there is iterative fidelity, does this present greater risk in areas such as technical debt? So, you know, I know we met at an event hosted, which one was it? I can't remember. Hosted with Elsevier, where they, you know, getting a load of programmers together, and they talk about this thing around technical debt. So basically, that you code, but your coding is not pretty shoddy, but you're putting rubbish comments in it that really is not helpful to anyone. And so this thing just gets bigger and bigger. And I think I'm just trying to bring.
I think that's technical debt. I think it's shoddy. To be honest. So I don't think that's technical debt. I think that's just shoddy workmanship, really.
Well, yeah, but I mean, going back to the point around iteration, about fidelity, you know, it's just about, well, you know, we've coded this in a way that it's enough to get us through over the line.
I think you're muddling up quality and fidelity.
Well, this is it. But well, quite possibly. But I mean, that's why I should have asked the question privately.
No, actually, there's no such thing as a stupid question, because it gives us something to think about as well.
No, it's good, because I think that, so yes, quality and fidelity are not the same thing, but in my head, if you're iterating, you're gonna have to redo things at some point.
Yeah.
Right, and that's perhaps what you mean here.
Yeah.
I think that's the actual point of working it in stages, because the whole point of doing it is so you can get some feedback. So you don't start out by going for high fidelity. You keep low fidelity, get some feedback, and then decide what you're going to do next. Right. So you might get to high quality, high fidelity at the end, but when you start, you don't know what that looks like. So I think each of these steps is actually to get some feedback. And I think that's the key to this fitting in with the agile approach.
So if you're completely 100% sure about what you need to build, don't build the low fidelity one.
But the point is that
you're never sure. Right?
Yeah, the point is you're never sure, right? So because otherwise you'll be doing design up front. And
yes.
The point is you're trying to get away from that, is because when you start out, you don't know what the best solution is. So you do a little bit low fidelity, get some feedback, learn, and then maybe change your course. So you end up with in a different place from what, because you've learned more. The whole thing is the learning journey that you'll know after taking the first step. You'll know more than you did before you started, and onwards and onwards.
Yeah. So I think there's kind of carry on.
So I think that when technical debt comes in, you're probably looking at a quality issue, not a fidelity side of things, because as a developer, you'd know that you're going to do a solution, but you may want to just trial it out. So you're not going to import a huge complex library. You might just pick one that is kind of easier to get through, probably free, just to play around with it. But as you iterate then and you increase that fidelity, you do need to go back and clean that up. But that should be part of the iteration to get you to then develop your product.
I think there's kind of a difference between a kind of purist perspective on this and a kind of pragmatic perspective. Because a purist will tell you that, you know, you can absolutely do everything at 100% quality, right? You can just do something simple. So if you look at like Airbnb, when they first started the feature where they could send a photographer around to take nice photos of your apartment for you, like literally it was a text box, you put your phone number in, and then there was some poor lady in the Airbnb office whose job it was to call you up and take your details, and then she'd go through the yellow pages and find a photographer that happened to be local to you, and then they'd go and they'd do the photos, then they'd come back and they'd assess whether it was any good or not. And they did that a bunch and then discovered there was value in it. And so then they went and they did a bunch of automation to make that a really slick process. Yeah. And in so doing, you know, they might have had a tiny bit of technical debt, which is the old feature of having that text box that they had to kind of take out. But really it was quite a sort of clean process. The kind of pragmatist thing says that if you're slow to market, somebody else will be quick to market and will deliver it before you do, which means that normally when you're in, you know, that leftmost, bottommost quadrant there, people aren't putting out the code that they're most proud of in their lifetimes, because, you know, they're people who've just quit their job to try and pursue a startup, and they've got a few features they really want to slap together quick, and they really want to get it to market to see if anybody will buy it, because their boss is still kind of friendly with them and they might be able to get back at their old job if they speak really nicely to him. And so I think that, you know, pragmatically, we often see quite a lot of technical debt in that kind of first little bit.
I think that one of the words you used there, James, was automation. And I think that's one of the areas where technical debt grows quite a lot, because you're never going to fully automate a process if you don't know you need it. So you build something, find out if it's needed. Yep, oh great, yeah, then let's automate it, make it fully scalable, all of those things, which you certainly wouldn't do if you're just putting it out there to test the market.
David, how many slides you got left?
Oh, I'm nearly there.
Okay.
Yeah, don't worry. Another aspect to me I was going to bring here is you know, building the right thing versus building the thing right, because iterating around things help with making sure you're building the right thing, right? So, and while doing so, you might increase the technical debt around building the thing right. Does that make sense?
Yeah.
So you're doing it's a balance act, right? You might be sacrificing some of the building the thing right method that you have, you know, making all the good engineering decisions in order to answer the other question, which is building the right thing. Does that make sense? I see you nodding, Nick. I think yes to your answer originally, but it's a good question because and it's probably a very subtle one as well. Am I doing a poor quality job just as an excuse to or am I doing this on purpose in order to answer that question? Am I building the right thing? So yeah, cool. All right. So looking at the time, the last thing I had was a little game. Again, I had made cards like this, and I wanted to do it, face to face, but we can't. So I had made like a bit like the game from David earlier, but more real life scenarios this time. So I don't know how it's gonna work, but I'm keen to have a go and try. So it's a bit of an experiment. So I've made this kind of 4 scenarios for us to look at. But I see it's only a few of us, so I don't know if it's going to work, but I'm just going to put them like this. Maybe we can just briefly take them one by one. I wanted to do breakout rooms at some point if there's too many people, which is a cool feature of Zoom, but I don't think we need to. So I've made these 4 scenarios, which are 4 projects I've actually worked on or similar things, and I thought it's a good idea to look at which bit would be incremental, which bit would be iterative, and how does fidelity fit into all of that. So just to show you what I mean, I was going to go through the first one if I find my notes again. So that calculation tool on the top left corner, yeah. So just for some context here, so it's a calculation tool. It's meant to replace a spreadsheet, an Excel spreadsheet that already exists. And different departments use slightly different versions, right? Because they've taken that version and they thought, oh yeah, I don't like that bit, I'll change it, right? And so the outputs are always slightly different in different parts of the organization. And there are hundreds of inputs and dozens of outputs. But again, they're all slightly different depending on which person has which version of the spreadsheet, right? And they're all floating around in people's local machines. And so the idea of building a tool was to harmonize all of that, right? To get rid of that mess. And then, as you can imagine, in a calculation engine like this, you would have lots of intermediate steps, and it's a big spaghetti mess of lots of calculations being reused in different places, and it's not a linear thing. It's quite complex sort of mesh of calculation, so that the output of one calculation becomes the input of the next, and so on. Yeah, does that make sense? So in terms of fidelity and incremental versus iterative, one thing that we did here was, okay, if it's a replacement, right, that means that there's an existing spreadsheet that they already use, right? So whatever we build is going to come into competition with that thing. So there's a certain amount of stuff, of features of calculation that need to be in place so that your new tool is valuable, right? Otherwise, if some bits of the calculation are not done yet, right, they can't use it. And if they don't use it, they won't use it. And they will keep going back to the spreadsheet, right? And it's something I see a lot in how Agile is implemented, is that you do your sprint demo and people turn up and they nod because they say, yeah, carry on. But really, they're waiting for the end, right? For the end product, because that's only then that they can actually build it, that they can actually, use it. And that's when you get the real feedback, but that's kind of too late, right? So for me, that means, okay, we have to iterate there, right? We have to somehow make the calculation, as rough as it might be, we have to cover enough ground that people actually use the thing as soon as possible, yeah? And the fact that there were, many inputs and outputs, so we could incrementally build the tool. So we have all the calculation building on top of other calculation, then start from the inputs, and eventually we would get the outputs, right? But that would take many, many weeks, if not many months. Yeah.
The output is still an Excel sheet.
Yes.
Okay. The fact that they're actually using Excel to calculate something, but okay.
A lot of people do that, right? Excel is rightly or wrongly, that's how it was, right? But the point here is that you could, as you develop the other tool, right? Let's say it's a web app, You could spend a lot of time trying to build up from the inputs all the calculation, and many months later, you eventually get to see the first outputs. And that's probably far too late, right? So I wanted to shortcut that length of time. So what we did was we kind of mocked all the outputs. We just faked the outputs completely. We've hard-coded them and just presented something with the outputs, which would solve already, hang on, I'm trying to find my pen there, the multiple version of the spreadsheet, right? Because we could say, okay, if you had these outputs presented this way, would that make sense, right? So we bypassed, we didn't do any of the calculations. We just presented the outputs as if the calculations were all done, right? And then backwards work out all the calculations by mocking things, mocking the inputs. And as soon as you implement the calculation, you replace the mock by the actual calculation, right? And therefore you could, so we would iterate on the outputs and how they look and which one you actually want, and the details of that, but then increment backwards to get to the inputs. Does that make sense? It's complicated. I hope I explained that properly.
It's interesting that there's a bit of a disconnect forming in my head between iterative or incremental development and iterative or incremental delivery. Because something like this, experience tells me that if you say, hey, you know what, we're just going to do one number right, and this tool is just going to deliver you that one number, people are going to say, well, I'm not going to use your tool for one number and a spreadsheet for all the other numbers. That doesn't make sense.
Yeah.
And then part of me thinks, okay, so we'll do it incrementally instead. We'll pick on Dave from finance and we'll get his understanding of it, and we'll make this thing work in the same way that Dave from finance's spreadsheet works, and the functions that he uses, they'll all stack up. But then again, from experience, you know that when you start doing it for Sally for marketing, actually you find out that the stuff that was important to her, it was really in conflict with what you've already delivered for Dave. And then you start putting horrible conditionals and clauses in your code, and you think, God, I wish I'd just sat down and written a specification for this thing in the first place, right?
But that's why we faked everything and just presented the output, right? So it was a quick way to get to the end result straight away and to validate, is this really what you need and what you want, right? And then we went around all the stakeholders, and so whatever her name is from marketing, we say, well, that's fine, but not quite. And then this other person would say, yeah, that works for me, but not that bit, right? And we would spend quite a lot of time making sure the product was correct, the vision of the product was correct before even doing any of the calculation, because that's too expensive. Does that make sense, right? So we would iterate on that a lot at first. And only once we got that right, working backwards towards the inputs to get the calculation correct.
And then, of course, you get something that is 80% right for everybody.
Yes. As opposed to 100% right for some people, and 0% or very, very little for others. Right? Does that make sense?
Is this, sorry, just to clarify, is this just another way of calling it prototyping or not?
Well, yeah.
It's sort of a fundamental problem, isn't it? You're right. And if you're trying to replace something that already exists, you have to get it to a kind of a minimum threshold before it's going to be useful to people, whether it's a product or sort of an internal application.
So just to, again, it's a real life scenario to highlight that some bits are iterative and some bits are incremental, right? So on this one here, the game here that I made up, I worked on something similar at some point. So shoot them up game, right, where you have people with a gun shooting things based on the comic book. There's an easy, medium, hard. There's lots of levels, but to complete the game, you have to accumulate clues from all the previous levels. And then some people have lots of ideas on what could be done. So if you want to think about that one for a second, but which bit would be iterative and which bit would be incremental, do you think? Or how would you use Fidelity to build this?
Well, I guess if you have to have the clues for all the levels in each level, then you need some sort of rough plan at the start, maybe some low fidelity, something that captures that element of it for each level. But you might build one level in the easy mode perfectly to be, well, not perfectly, but to a higher fidelity to begin with, and then work through it. But yeah, I know zero about games development.
Well, game is a funny industry because the funny industry games because it behaves a bit like films, right? You have a release date and
the
whole marketing campaign before, so it's quite an industry to work on.
Basically, what another approach would be: you start with the easy mode, and you start building your 9 levels for easy mode, and then you start thinking up on how you can make it more difficult. So, and then you can expand on your puzzles, on your things, either add more or change them a little bit or whatever for your medium, and then the next level would be the hard mode.
So I'll tell you what we did in that case. So the problem that I faced on that project was that the development team just wanted to build every level one by one, so incrementally, at full fidelity for each level, and only think about the whole clue and the final level at the very end of the project.
Okay.
Right, because I just want to do my level 1. Why are we waiting? Right, I just want to build level 1 really well, because I don't want to do shoddy work, like we mentioned that word earlier. Right? But it was really hard to convince them that, well, actually, it's based on a comic book, and we have the whole clue thing is probably the most important of the whole thing, in terms of you're building a narrative, and because it's based on the comic book, the people who are going to buy that thing are really keen on that comic book. You can't just make something that doesn't fit with the comic book, right? It has to. The narrative is perhaps the most important thing here. So we really had to think hard about those clues right up front. So things that goes back to what you were saying, Mali, about some sort of a plan already of what those clues are going to be. So it goes outside of the software development, right? But the vision was kind of worked out straight from the start, right? In terms of what this game is going to tell, the story behind, and all of that. And we had to build the levels iteratively. So we had all of them kind of, and when I say iteratively, it wasn't even software at first. It was just drawings on the board, right? Like a storybook, literally, right? Like how people write books, right? And sketches. Okay, you're gonna have that clue. This is gonna happen, and then you're gonna have this bad guy at the end, and it's gonna be hard this way and easy at this point, and just like you're telling a story. And in terms of how hard it was, we kind of started there, in fact, with the hardest, because that was harder to implement. It was easier to make it easy later than, right? So we started there really, in terms of reducing risk, right? And then incremented by doing this and then that, right? And making it easier and easier. But we definitely started on hard, but at a low fidelity in terms of graphics and the UX of the game itself. Does that make sense?
I guess it depends where the risk in the project is perceived as being, doesn't it? In large part will be determined by whether you're working with a gaming engine or not. Because if you've got a solid gaming engine, you kind of know that the gameplay fundamentals are going to be good. Because you're writing a game, the most important thing is this going to be fun to play? And if you're trying to establish whether it's going to be fun to play, then you probably want to do a level pretty good, so you can give it to some people and say, would you play this? Is this fun for you? If on the other hand you've got an established engine where people kind of know that it's going to play nicely and it's going to be good, then all of a sudden you're talking about, well, what's success look like? Success is a compelling narrative with beautifully designed levels, and so you're almost skipping to that's the bit that we've got to make good now, is the storyline, rather than the actual ins and outs of jumping and punching and stuff.
Exactly. Yeah. Exactly. And then if you look at games like the Wii, right, where the graphics are really low, really like sort of really low resolution, and a proper gamer would look at this and go, "Bah, this is rubbish game." The resolution, where people in the gaming world kind of expect quite a lot now of games, right? And people who play the Wii are like like my mum, right? My mum plays the Wii, but not the cool 20-year-old gamers, right? Not necessarily. Well, they might do as well, but for different reasons, right? So yeah, you have all of that to take into account. So it's a difficult industry. Just looking at the time, I'm gonna keep that one and then go to control system, because that's something that I spend a lot of time working on. So there was a futuristic dashboard was the vision, right? So it's for a scientific research lab, right? And they have lots of instruments to do their science, and they wanted something really cool, like imagine the most futuristic movie you've seen recently. It had to look like this, like Star Trek, right? Where you that's their vision, and of course they knew we might not reach that, but it was kind of the goal in their head, right? Eventually, and now some experiments that they wanted to run, well, all of the experiments they wanted to run, really required all the instruments. You could not have a missing instrument, right? Otherwise they can't do their experiment. And some instruments, they could be done with manual operation. So you didn't need any software. You could just go on it and manually turn things and, and switch things on and off, etc. But equally, some instruments had to have a software interface, because there was no like a control panel, no hardware panel, nothing to switch on and off. It was purely a software interface. So we had a bit of a mix there. So again, I'll just give you a minute just to think about that one, because it's quite interesting. So whether what would you do iteratively or incrementally?
Start with a simple user interface. I suppose that's the sort of fidelity thing, isn't it? Mm-hmm. But you need to cover, I suppose, all of the features that need to be done by software. So you could ignore the manual bits initially. So you have a first sort of iteration, I guess it would be, wouldn't it? Which just deals with the things that have to be done in software with a very low fidelity user interface. Make sure you've got a good understanding of the mechanics of how the thing has to work, and improve the fidelity to get to the right sort of level of user interface. And then you could go back and incrementally, I guess, add the additional controls that you left off the first version of it.
So for me, the futuristic sort of dashboard was hard, because that meant that the expectations was for high fidelity, right, on everything, which you have a problem from the start there, because they expect something really neat, really funky, really kind of modern, etc. But at the same time, they had this requirement, right, that we need everything, right? We need all of it, and we need it now, kind of thing, which is not a requirement you see often, and those two things were basically in contradiction. So we had to use the fact that some were like this, where you could just skip them altogether. They were just the lowest priority things you could think of, because they didn't need to. So there was the low fidelity solution for those ones was to not build software at all, right? They would just keep doing it manually. But equally, those guys, they had to have something. And because there were so many different features on this hardware, you had to kind of cover them all, because it depends on the experiment, what they use, what they don't use. So they couldn't tell you which ones, they couldn't prioritize the features on those instruments. They had to be all there, right? So those bits, we had to kind of iterate, right, on those features, but make sure they were all there. These guys, we had very low fidelity again, as I said, but then we had to do like an MVP, if you wish, where we had the whole level, right, of all the instruments had to be operational in some shape or form, right, but covering all the features. And so we had to sacrifice some fidelity. So we had to sacrifice that basically, right, at first. It just had to work. And then we, sort of iterating towards a more funky dashboard. But of course, we knew that from the start. So we chose the sort of technology that would allow us to do this, right? because otherwise you shoot yourself in the foot. Right? You have so much technical debt. Going back to what you said, Nick, right? But you had to make the right choice in terms of knowing that vision, so that you can actually get there, as opposed to have to, in a year's time having to rewrite everything. That was not going to be a good thing, right? If you have to rewrite everything. Does that make sense?
Good architecture comes into the picture here somewhere, doesn't it? If you can, if you can sort of separate out the user interface from the rest of it, you should be able to replace your low fidelity interface with something much more futuristic later, without having to go back and rewrite all of the kind of the mechanics of controlling these external systems. That's kind of works in this context.
Yeah, which is always tough, right? You have to make decisions up front, and they might not be the right ones, right? But the key in architecture, I guess, is to make things, how would you say, things that are easy to change, right? That's the key, right? If you make things easy to change, then you can change them if you have to. So you might need a bit of a flair, right, to know which bit do I really need to make easy to change, because I've got a feeling it will change, right?
So did you have at least luxury of a lot of resources to work on this, so you could do a lot of things at the same time?
I was basically the only person on this for a good 3 years. And then, so it was very slow, right? But we knew the experiments were coming. There was a proper deadline when the experiments were going to start. But then at some point there was a lot of people, because we had to get it all done really quickly. So at some point people realized, okay, this is not going to work. We need people to get that going.
Okay, interesting.
Cool. Right, I'm just looking at the time. There's like 2 minutes left. Any thoughts on this? Like the whole iterative versus incremental and fidelity? Was it useful? Did you learn?
Very interesting. Thank you.
Yeah, it's useful, definitely.
Yeah, really good discussion.
Cool, thank you.
I really like the graphic with the bars a lot. Those things.
The 3D graphs.
Yeah. Really like
That's
that.
good. That's all from Carl Scotland. I just stole it all from him.
Excellent. Good work.
I just think you're really brave doing this online. So thank you.
Well, yeah, I know, and it's difficult. It's not easy. Like the poker thing didn't quite work as well at the beginning, but it's fine, right? I'm excited. I'm quite happy to try things out and experiment. So yeah, anyway, I hope it was useful. Thank you for coming. Thank you for your time. And I'll somehow share the recording some way or another. I'll have a think about that at some point. Okay, good. Well, have a good evening. It's late.
Nice to see everyone.
Nice to see you, everyone.
Yes.
Nice to meet you for new people. Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye.